Okay, we've got one last theorem about polynomials that's going to help us find some of the zeros. Okay, so it says if you have a polynomial with integer coefficients and you have a rational zero of your polynomial, so this only works for rationals, then the numerator has to be a factor of the constant, the a0, and the denominator has to be a factor of the leading coefficient. Okay, so what this means in theory is that you could write out all the possible ones and then actually find some. Okay, so if we want to find the zeros of x to the fifth minus 3x to the fourth minus 3x cubed plus 9x squared minus 28x plus 84, so if we have zeros of the form p over q, p must be a divisor or a factor of our constant 84, and q must be a factor of our leading coefficient here is 1, which the only ones there are positive or negative 1. So we know q must be positive or negative 1. Now, for our p must be a factor of 84, so we'd have to write all the factors of 84. Well, we'd have 1, 2, 3, 4, 5 doesn't, 6 would, 84 divided by 7, yep. Eight's not a factor. 9 is. 10 isn't, 11 isn't, 12 is. Okay. Now we know we can't have anything bigger than that because if something's already bigger than the square root of it, or if the square of it's already bigger, then you can't have anything that you've missed. So then we would also have 84. So if we wanted to list all the possible ones, we'd have plus or minus 1, basically plus or minus any of these, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 7, plus or minus 9, 12, and 84. Now, not all of those would work, but what you could do is put this in your y1 and then use your table to check if these are zeros. Now, it says use synthetic division to show that 3 is a 0. Okay, so if you find that one is a 0, you can do synthetic division to then help factor it. Okay, so we would have 1, negative 3, negative 3, 9, negative 28, and 84. So we'd have 1, 3, 0, negative 3, negative 9, 0, negative 28. Oh, I guess we did miss some. Because 28 would have been up here. But anyways, we would list all the factors of 84 up there. Okay, so what we're saying here is that our quotient is x to the fourth minus 3x squared minus 28. Now, this is actually of the form that we could use the u substitution and turn it into a quadratic. So we could say let u equal x squared, then we would have u squared minus 3u minus 28, which would factor as u minus 7 and u plus 4. Okay, so we'd get u equals 7 or u equals negative 4. So if x squared equals 7, then x would be plus or minus the square root of 7. And if x squared equals negative 4, we take the square root and we get x equals plus or minus 2i. Okay, so our 5 zeros now, we knew that 3 was a 0, and we just found 4 more. Square root of 7, negative square root of 7, 2i, and negative 2i. And if we want to write it in factored form, our polynomial would be x minus 3, x minus the square root of 7, x minus a negative, which will become plus square root of 7, x minus 2i, and x minus a negative 2i will become x plus 2i. And that is our polynomial in complete factored form.